Now let's try to determine the parts of the parabola of the following equation and sketch the graph. So I will be showing you equations and we just have to identify the parts based on the equations given. Let's start with the first example. X squared equals 4 times y plus 1. So first thing that we have to identify is the opening. What is the opening of the parabola? Now, in order for us to identify the opening of the parabola, it's easy if we will identify which variable is being squared. In this case, since as you can see, x is being squared, that means it opens either upward or downward. So it follows now the form x minus h squared equals positive or negative 4c times y minus k. Now let's write here the opening. For the opening of the parabola, we just have to look at the value of 4c. So as you can see, 4 here is positive. That means it opens upward. Now after identifying the opening of the parabola, let's now identify the vertex. Now we know that the vertex is hk. So from the formula, let's rewrite here into its standard form. Though this one is already in standard form, but we can write it as x minus 0 squared equals 4 times y plus 1. So x minus 0 is just x, you square it, you will get x squared. Now, h is the one that is with x and then the k is the one that is with y. So the h here is 0. So we have 0, comma, then for k, since we have here plus 1, originally the equation is minus k, therefore the value of k here is negative 1. So y minus negative 1, that will give us y plus 1. Okay, so the vertex is 0, negative 1. After the vertex, let's now identify the focal length. So the focal length is our C. So we will try to identify that because we cannot solve for the other parts of the parabola without C. So in order to identify C, we have to look at the 4C here, which is in this case is 4. So we know that 4C is equal to 4. Again, this one right here. And then just solve for C. So just divide both sides by 4. So we have C equals 1. So the focal length now is 1, or C equals 1. Now that we already have the focal length, we can now identify the focus of the parabola. So focus. So to identify the focus, since the parabola opens upward, that means it follows the form of h, k, plus c. And we already have the h, we already have the k, and then the c also. So we can write here, h is 0, k is negative 1, and then plus c is 1. So plus 1. Therefore, the focus now is 0, 0. So this is now the location of the focus. 0, 0. For the directrix, since it opens upward, it follows the form y equals k minus c. So we have the k, which is negative 1. We have c, which is 1. So negative 1 minus 1. Therefore, the directrix or the equation of the directrix is y equals negative 2. And lastly, we have to identify the axis of symmetry. For the axis of symmetry, since it opens upward, so it follows the form x equals h, and we know that h is 0, so our axis of symmetry is x equals 0. Now we can graph the parabola using the parts. So it opens upward, So it's something like this. So the axis of symmetry is x equals 0, which is just our y-axis. So something like that. And then our vertex here is, this one is 0, negative 1. So let's write here the x-axis. Okay. And then the focus is 0, 0. So this is the origin. So this is now the focus, 0, 0. And then we have the directrix, which is y equals negative 2. So this is negative 1, then negative 2. So this one is our directrix. So the horizontal line, which is y equals negative 2. So that's roughly how our graph should look like given the equation and the graph. If you want to identify exact points from the parabola, then you can identify values of x and y, then substitute. Next, let's have this example, y equals negative 4 times x minus 3. So let's identify the opening of the given parabola. Since the variable that is being squared is y, that means it follows the form of y minus k squared equals negative, positive negative 4c times x minus h. Therefore, it opens either to the left or to the right. But since the 4c here is negative, so that means the opening is to the left. Now, let's identify the vertex of the given parabola. We can rewrite this equation into y minus 0 squared equals negative 4 times x minus 3. So y minus 0 is just y, you square it, you get y squared. And also take note that h is the one that is beside x, and then k is with y variable. So therefore, the vertex is 3, 0. Now let's identify the focal length. So for the focal length, we have to use 4c. So in this case, 4c is negative 4. So we equate this to 4c. So 4c equals negative 4. Then solve for c. Divide both sides by 4. So we have c equals negative 1. Now, after identifying the value of c, we can now identify the location of the focus. So, since it opens to the left, that means it follows the form of h plus c k. So, h is given. So, we know that h is 3. So, 3 plus negative 1 or 3 minus 1. And then k is 0. So, we have here 0. So therefore, the focus is located at 2, 0. For the directrix, so since it opens to the left, that means it follows the form of x equals h minus c. So x equals, then h is 3, minus, then our c is negative 1, so minus negative 1. So this will just become x equals 3 plus 1, or the equation now is x equals 4. So that is now the equation of our directrix. And then last is our axis of symmetry. Since it opens to the left, that means it follows the form of y equals k. And since k is 0, so the equation of the axis of symmetry is y equals 0. Now that we already have the parts, we can now graph the given parabola. So let's draw a Cartesian plane first. Now let's identify the vertex in the plane. So we have 3, 0. So that is 1, 2, 3. 3, 0. So right there. And then let's draw a parabola that opens to the left using the vertex. So something like this. There. And then Let's identify now the focus. So the focus is located at 2, 0. So 1, 2. So this one right here. This is our focus. Now for the directrix, it is x equals 4. And since it opens to the left, that means the directrix is a vertical line. So you just have to identify where is x equals 4. So 1, 2, 3, 4. So here. And then from there, let's draw a vertical line. So this is now our directrix. And for our axis of symmetry, it's y equals 0. Or in short, that is just our x-axis. And as you can see, the x-axis cuts our parabola into two congruent regions. Next, we have x minus 2 squared equals negative 12 times y minus 2. So obviously, it follows the form of x minus h squared equals positive or negative 4c times y minus k. And from here, we can already identify the opening of the parabola. Since 4c is negative, which is negative 12, therefore it opens downward. Now for the vertex, you can easily identify the vertex. So the one that is with x is our h, and then the one with y is our k. Therefore, the vertex here is 2, 2. Next, let's identify the focal length. For the focal length, we need to solve for 4c. And the 4c in this given equation is negative 12. So equate 4c to negative 12 and then divide both sides by 4 to solve for c. So we have c equals negative 3. So that is now the value of c. And then let's solve for the focus. Or let's solve for the location of the focus. So since it opens downward, that means it follows the form of h, then k plus c. So h here is 2. So we have 2, and then k is also 2. So we have 2. And then plus negative 3, or this will become 2 minus 3. And then solve. So we have 2. 2 minus 3 is negative 1. So the focus is located at 2, negative 1. Then let's solve for the directrix. So since it opens downward, it follows the form of y equals k minus c. So y is equal to k, which is 2, minus c, which is negative 3. So this is just y equals 2 plus 3. Or the equation now is y equals 5. So that's the equation of our directrix. And then last, axis of symmetry. For the axis of symmetry, it follows the form of x equals h. Since h is 2, so the equation is x equals 2. Now let's graph this. So let's draw a Cartesian plane. Okay, something like that. Then identify the vertex. So it's 2, 2. So 1, 2. 1, 2. So we have here this point right there, which is the vertex, and we know that it opens downward, so that means 2, 2 is already the maximum value. So let's draw something like that. Parabola that opens downward. Then next is, let's plot the focus. So it is at 2, negative 1. So we have 2, negative 1. So here. So this is our focus. And then for the directrix, it's y equals 5. So let's just identify where is 5 here in our y-axis. So you have 1, 2, 3, 4, 5. And then you draw a horizontal line from that number. So that gives us the directrix of the parabola. So for the axis of symmetry, we just have to identify where is x equals 2. So we have 1, 2, this one, and then you draw a vertical line. So let's say it's something like this. And it should pass through the focus and the vertex. There. So that's the graph of our parabola with its parts. And for our last example, let's have y plus 4 squared equals 8 times x plus 2. Since the variable that is being squared is y, so it follows the form of y minus k squared equals positive or negative 4c times x minus h. So let's identify first the opening of the parabola. Since y is being squared, it's either opens to the left or to the right. Now 4c here is positive, which is 8, so that means it opens to the right. Then let's identify the vertex. So from the equation, so as you can see, the signs here are both positive, and originally we know it should be negative. Therefore, we have to get the numbers and then change its signs. So we have here, this one is k, this one is h. So for h, instead of just writing 2, we have to write negative 2. Now why negative 2? Because the original sign here is negative. So if it's x minus negative 2, that will give us x plus 2. Same as with k. Since this one is positive, all you have to do is just to change the sign. So it will become negative 4. Since the original equation, it should be negative. So if you substitute here y minus negative 4, that will give you y plus 4. So this is our vertex. Then let's solve for the focal length, which is c. So again, use 4c. And the 4c in the given equation is 8. So 4c equals 8. Divide both sides by 4. So we have c equals 2. Then after that, let's solve for the location of the focus. Since it opens to the right, that means it follows the form of h plus c k. So h is negative 2 plus c, which is 2, and then k is negative 4. Simplify this, we have negative 2 plus 2 is 0, and negative 4. So this is the location of the focus. Next, let's solve for the directrix. For the directrix, since it opens to the right, so it follows the form x equals h minus c. So we have x equals, then h is negative 2, then c is 2, so negative 2 minus 2, or the equation of the directrix is x equals negative 4. And last, axis of symmetry. For the axis of symmetry, since it opens to the right, it follows the form of y equals k. And we know that k is negative 4, so the equation is y equals negative 4. Then let's graph the parabola using the parts. So we know it opens to the right, so let's draw a Cartesian plane. So let's identify the vertex 2, negative 4. So 1, 2. Let's write like that. So 1, 2, negative 4. 1, 2, 3, 4. So there we have here this one. This is the vertex. And then let's draw a parabola that opens to the right. Okay. And then we have the focus, which is 0, negative 4. So 0, negative 4. 1, 2, 3, 4. This one right here. And then we have the directrix, which is x equals negative 4. So just identify where is negative 4 to our x-axis. So 1, 2, 3, 4. And then draw a vertical line. So there. So this is our directrix. And then for the axis of symmetry, you identify where is negative 4 to y and then draw a horizontal line. So 1, 2, 3, 4. Then draw a horizontal line. So it should pass through the vertex and the focus. So that's the graph of the given equation. Alternatively, you can also use the Desmos in graphing as well as the GeoGebra. All you have to do is to input the given equation and then also input the other equations such as the directrix and then the axis of symmetry. So that's it for today. I hope you learned something about the parts of the parabola as well as the graph of a parabola, and see you next time.